A rover is traveling across the surface of Mars, which causes dust to accumulate on its solar panels. The function R of P shows the rate at which dust accumulates, in milligrams per kilometer, along the rover's 100-kilometer path. How can you use this to determine whether the rover will accumulate more than 200 milligrams of dust?
So I think how we want to do this would be a Riemann sum. So for Riemann sums, we're going to multiply the length of our intervals, whatever we decide that to be, times the value at those points of the interval.
Okay.
So what do you think are, I guess, so that's the length of each position interval. What should we have that be?
I guess like if we're going from 0 to 100, what if we just say our d is equal to 10?
Okay.
We'll set d equal to 10.
Okay, so I guess we could like try to draw these in.
So it'll be like here down.
So that one's a left Riemann sum because we took the points.
I think like if you can see here, like we'll have like overestimates in this case. Okay, so in the chart, I guess we can, if it's like length 10, we can fill in like, yeah, could you do this really quickly? So 10.
So, and then, that's nice. So like these values are going to be like the area of the rectangles.
And you were saying before about like this, like doing the Riemann sum, you would add up all the areas. So would you end up adding like these up? Like, is that what you're doing? Okay.
Where we took that in.
Okay.
So we want the sum from
1 to 10.
1 to 10 of. So this, with our overestimate, we get something that's like 230-ish.
It's bigger than 200.
So that would mean it wouldn't work.
But
then again, this is our overestimate.
So should we then try the right-hand side and see what our underestimate is?
Yeah.
Okay.
So that would be like ours. That would be like these. So we'd start from 10, go to 100. So I think that would mean these would go from 2 to 11.
And that's like significantly less.
Which I guess that doesn't really help us much because if our overestimate is over, like the rover might not make it. But then if it's the lower estimate is under, then that means like there's a chance that it could. Whereas if our lower estimate was over the 200, then that would mean like we know for sure it wouldn't work.
Yeah.
So I think we need to change. I mean, the only thing we have to change is our the intervals. So maybe if we make them smaller, maybe we can get a more maybe we can get a smaller interval.
Yeah.
So we can figure out where we're going to be.
So like, are you thinking like let's cut it in half? So do like d equals 5?
Sure.
Great. Okay.
But then that also means we have to change
The chart.
So okay. Now we also have to change this. So we want.
So if we're doing a left hand,
We want 20.
20,
And
and the bottom would be 1.
Okay.
So our left hand, where it's still going to be an overestimate, is getting us a little closer to 200, but it's 213 now.
Mm-hmm.
And what happens if we do?
And that's still under. So that's not going to work either.
So we're not really sure if it will make it or not.
Mm-hmm. Like we'd have to get something that's a lot more accurate
Mm-hmm.
than the intervals that we currently have.
Mm-hmm.